Hello, relativity friends. Yesterday, I published a video on expanding the Christoffel symbols as a question, as a request, and I completely screwed it up. I'm really sorry. I just got this message. You can see 34 minutes ago, just down in the table. I see the first covariant index and the first contravariant index always coincide. Why? And I thought to myself, well, that's not right. So thank you for asking this question because I wouldn't have looked at it again. I went back and looked what I published and it was just completely wrong. Completely wrong. I apologize. Let's do it. So let's do it the right way. Okay. So here's the generalized equation for the Christoffel, the symbols. Okay. Now remember, we have here the free indexes, I, J, and K. And what you see on this side of the equation that's not on this side of the equation is this M. So this M is in the upper position here, and once in the lower position, that means it's a summation index called a dummy index, right? So if it's over here and not over here, it's a dummy index, a summation index. All right. So we're going to work in space-time, the coordinates, right? So we have 4 dimensions, time, and 3 spatial dimensions. So we're going to let these equal 0, 1, 2, 3. So time is 0, etc. 1, 2, 3. Okay. So here's the way. Here's the way you actually do it. I'm so embarrassed. Okay, since this symbol has 3 indices and we're in 4 dimensions, there should be a 4 to the third, should be 64 Christoffel symbols. Okay? But remember the couple of videos we did on the fundamental theorem of Riemannian geometry? Well, we learned that since these are the Levi-Civita Christoffel symbols, they are symmetric about their lower indices. So therefore, there are actually only 40 independent ones. Okay? So there's 24 reproductions of these 40. All right. So let's look at how it should be done. Okay. Let's do set number 1. So there's going to be 4 sets of 16. All right. So let's let k equal 0. So that's for the contravariant index. And for the covariant index, we do all of the permutations of 0, 1, 2, and 3. So it looks like this. Okay. Now let's look at this. So because of the fundamental theorem of Riemannian geometry, this one, O1, with the upper index 0 is equal to this one, upper index 0, 1, 0. These are equal. So if you count the number of ones that are independent, you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 per this block of 16. So it's 10 times 4 is 40. So there's 40 independent ones. Okay. So now we change this upper index, or contravariant index, to 1, and we do the next set. So you find all the permutations of this, and you get this new set, which has 10 independent ones. Okay. And then you do this again with 2, and you do this again with 3. So you get 64 total Christoffel symbols, 40 40 of them are independent. Okay, man, I just can't believe how far off I was on that. It's really embarrassing. I took it down and burned it. It was just and luckily I did this part right. Okay, so we just picked 1, 0, 0, 0. Okay, so here are 3. The free indexes are 0, 0, and 0. And now we have to do an expansion, the summation from m equals 0 to 3, right? So in the first case, m equals 0. The second case, m equals 1. The third case, m equals 2. The fourth case, m equals 3. So each one of these has 4 terms. So there's 64 of them, and each one has 4 terms. So what's that? 256. It's a lot. Okay, so that's the way it should be done. And once again, I'm sorry. And if that's not clear, ask again. All right, thanks.